Okay, in this video we're going to be talking about two parts. We're going to be talking about the adjustment of the body tube length and the nose cone size, shape, and even material. Let's start with the easier of the two. Let's start with the body tube. Now remember, you may change the body tube on the booster section, not the payload section. The payload section is here. I'm going to go ahead and select up here in the upper left-hand corner. I want this to remain untouched. This is a 4-inch tube. Leave it, don't change it. This section, we call this the booster because what gives it the boost is that engine. The booster section tube may be changed. Now I'm going to go ahead and click on body tube here, and you'll see that this is getting highlighted. To change this, I'm referring only to the length. Do not change the diameter or the wall thickness. Okay, so I'm going to go ahead and double click on body tube here. This is actually quite simple, and I have many ways to do this. One of two is either hitting the up or down arrow only for the body tube length. Do not change the outer, inner diameter, wall thickness. Do nothing here, please. Do not change the material. Do not change the finish. The only thing you can change is the length. Now, you can either hit the up arrow or the down arrow. And as I've mentioned in my previous video, these arrows typically change by 1-inch increments. And that may not be what you want. So right now, we're at a stability of 2.04. An apogee of 807. This must be using the C engine motor. And we can see here if I make the tube longer, I should be adding more mass, more surface area, more drag. This number should actually go down if I make the tube longer. Let's go up by 1 inch. Yep. So I dropped just over almost 30 feet here, but I also go up in stability. Let me make it even longer than our original 7 inches. You can see the stability is becoming more stable or overstable because once again between 1 and 2 is ideal. 2.67 is an overstable rocket, but you can also see I'm coming down in apogee. So it's what we keep referring to, surface area. If you increase it, you increase drag, you increase mass, and in this case we can bring the rocket down because we've created more drag. Okay, now if I go the other way, let's go down. 7 was the original, 2.04, 807. If I make this tube shorter than 7, I want you to keep an eye on what's happening here. This is where we're going to have to kind of just pause for a moment and look at all the pieces and parts that are inside this body tube. We have an engine. We also have a recovery system, it looks like we have here. And we also have some space required also for some flame-proof wadding. I'm going to tell you right now, I'm going to ask you not to make this. I'm going to put this number at 5. I do not want this tube to be less than 5 inches in length. Because the problem with making the tube shorter and shorter, as we can see here, the parachute is now inside, or better yet, where the engine, this is not feasible. So we're going to tell you, we're going to say right now that a 5-inch tube would be the bare minimum that I would want a student to make this booster section. Now remember, lengthwise, you can keep going, but there's another thing I mentioned in my specifications, the overall length of the rocket. I want you to look over here. Currently, the length of the rocket overall is 17.455. I told you that the rocket could not exceed 24 inches. I'm just going to keep going. Okay, so I'm going to make this rocket tube 15.5. Okay, there it is, folks. This rocket, this is a beast here. Look at this thing. Obviously, I probably wouldn't expect any student to do this. Look at my stability. Way over stable, 4.7. I've dropped significantly in apogee, over 200 feet, but I did put a number of 24 inches. So this is where the rocket will definitely start to change overall length by adjusting the tube. Now remember, I just doubled the length of that tube. Let's bring this back down to roughly where it used to be. I'm going to type in 7. Okay, roughly, it was probably a little bit above 7. I'm going to keep that at 7. Now you can use the slider here as well. Okay, but we're going to keep that once again close to what we originally had when we started this rocket. So as I mentioned in my previous videos, if I want to return this tube back to its original state, okay, watch this. I'm going to leave it at 7.8. Remember, only option you have is body tube length. I'm going to hit close. But if I want to return it back, I can say Control Z. There you go. Control Z will bring me back to my original length of 7.087. Okay, so body tube length can be changed. Remember, no shorter than 5. And make sure if you increase, we're not making an overall rocket of 24 inches, no longer than 24. Now, I want you to look at this number here, 0.976. This is going to now get us into our nose cone. If I go back to body tube again, the diameter, this is very important, the diameter that we have here for these body tubes is listed here. You have an outer diameter and you have an inner diameter, okay? So the outer diameter is 0.976, the inner diameter is 0.819, okay? And let's take a look at this tube right here. You can see they both match up. So it's very important that we understand how this plays a role in finding the right nose cone, okay? Let's look at that inner diameter, 0.819. So let's close this and let's now go to our nose cone here. I'm going to double click on nose cone, okay? The base diameter of this nose cone, base diameter says 0.976. So this is a very important number here. We're going to have the option to change the nose cone. And here's what this could do for you. It could obviously change the aerodynamics of your rocket. But here's where you could add weight or reduce weight, because I'm going to let you really have some fun with the nose cone. Now remember, you can't pick any nose cone. It has to be a nose cone that follows this base diameter. So let me show you how we would either manipulate what we have or find a new nose cone. Like I said, you can change the material here. You can change it from a polystyrene, which is the plastic. You could try basswood. Now watch, 808, 2.04. If I change it to basswood, I'm assuming that's going to have some change, okay, slight change. It could be brass. Look at the difference. 0.098, basswood 0.28. Look at this, 4.97 ounces. Oh my goodness gracious, a lot of weight. And I have a feeling that stability is going to change significantly. Oh my goodness gracious, 6.1, okay? So and look how low my rocket went. My rocket went down to 220 feet. Because I'm literally having a metal type nose cone. But I have different materials. I've got PVC. I have all these different options here. I'm more than happy to let students change and experiment with material for nose cones, even the finish, which is the paint job, unfinished, rough, regular, smooth, polished, okay? But here is, once again, let's take this back to balsa. Here are those things, once again, you can manipulate. You can manipulate the shape parameter. You can see it gets almost to a tapered sharp point. You can manipulate the nose cone length. Okay, now remember, keep in mind, if you make the nose cone longer, you're also making your rocket longer, okay? And we can not change the base diameter. This has to remain 0.976. Very important you never change this. If you were to change this number, you'd make a tube that's wider or narrower than the tube we're using, which means it would not be compatible. Now the wall thickness, I'm going to just be honest with you, the wall thickness is something you can't really see right now, but what I'm changing here, and it's going to max out, is the actual thickness of the material that makes the walls of the nose cone. That's going to add more mass, more than likely, to the rocket, okay? So I'm just going to let you know right now, you can't have zero. Zero would not be something. I'm going to hit close. Let me hit Control Z. Just bring my rocket back to its original point here. Let me go back to my nose cone. So I'm going to make two executive decisions right here, folks. Keep the base diameter for right now at 0.976, and let's just be careful with the wall's thickness. It should have some type of thickness. Zero is not considered a thickness. So anything above zero is fine. Okay, so just be very careful here. Here's the big one, 0.976. Watch this. Let's go custom. 0.976. So I'm going to come up to Select Preset from Database. And here's how I'm going to look at my options. I'm going to go to this aft outer diameter. Okay, watch this. Aft outer diameter. I'm going to click here once, and it's actually going to put these in order of size. I'm going to make this window much bigger here, and I like to always keep this and this visible, my stability and my apogee. So 0.976, let's scroll down here, and you need to find a nose cone that's in the 0.976 aft outer diameter. There we go. And you're going to have a pretty long list. We have starting from this Estes balsa all the way down to this Semrock. Okay? These are different shapes of nose cones. Watch this. Let me go and select, move this out of the way. It'd probably make a little bit more sense to see the nose cone along with things like your stability. So let's go ahead and back that up just a little bit right there. There we go. So we have these different options here. We have conical, blunt, fat, special shape, plastic nose cone. Let's try this one right here. I'm going to hit OK. Okay. You can see a little bit of a change. Let's go ahead and go back. Let's go to the database. Remember, we want 0.976, so I'm going to go ahead and put these in order again. And let's go down to the 0.976. Okay, let's go ahead and use an elliptical. Okay, once again, you can start to experiment. Remember, don't change the base, but the length can be changed. I could actually make this one shorter. Look at that. I can make it shorter. I can make that longer if I needed to. Okay, let's once again be careful with the wall thickness. It should be something above 0, please. And I will let you change the material, which is going to add more mass. But goodness gracious, folks, look at the difference now of my CP and my CG. Extremely overstable, which is why this is only going 258 feet. Remember, this used to go close to 800. So aluminum probably had a big to do there. There we go. Going from a metal to a wood nose cone has a significant difference. But once again, that can be used to your advantage by experimenting with different materials, lengths, shapes to help bring the rocket down and or to increase apogee, make it lighter. Okay, so once again, that's our nose cone and body tube. Remember, don't change the base diameter, please, and look for a nose cone if you're going to replace it. And remember, Control Z, let me hit Control Z, can always bring the rocket back to its original state. So we're going to end the video here. We have just one more video left.